and welcome to another edition of HISD at Home. My name is Alissa Howell. I'm the Secondary Director for Mathematics, and I'd like to work with you today on some middle school mathematics. We're going to start in grade 6 looking at area, and then we're going to extend that understanding into volume. Please remember that all of the activities that you'll be seeing today can be accessed from the HISD at Home website. You'll look for the resources for middle school parents and students, and then select the appropriate PBL lesson from the links provided. Now, are you ready? Let's start in 6th grade. This week, we're going to be focused on calculating the area of triangles, squares, rectangles, and circles. And then we're going to use that information to create parallelograms and trapezoids and calculate the areas of those figures as well. And then we're going to put them all together and to calculate the area of a composite figure. Our guiding question is, how do you find the area of composite figures? And this is really just where we're starting. By the end of this project, you're going to create a piece of art that you can give to someone that we're going to define as your muse or someone who inspires you. In your art project, you need to use at least 3 different shapes, and you want to be very careful that you draw them with precision. In the end, you should have a total of 12 figures that do not overlap. We're going to ask that you determine the area of each figure and record it in the recording chart. Your calculations must be correct. And this is an image of what the recording chart looks like. Notice how it's asking you which shapes you chose. Maybe it's triangles, maybe it's trapezoids, but you're going to list those down. You're going to give the measures of the figure and then calculate the area. And in the end, we want to figure out the total area for our shape. At the very end, you're going to have a rubric that you can use to score the project. Please make sure that you reference the rubric when you're checking to see if you're done. At the end of Monday's lesson, you should understand how to calculate the area of triangles, squares, rectangles, and circles. You'll notice that some of this is review from 5th grade, such as the area of rectangles. And we're also starting to extend you into the area of circles, because that's going to be an important concept when my 6th graders, all of you guys, go into 7th grade. On Tuesday, we're going to ask you to calculate the area of parallelograms and trapezoids. And the way we're going to do that is using our understanding from what we already know about triangles, parallelograms, and rectangles. On Wednesday, you're going to start making composite figures. And once you learn how to calculate the area for those composite figures, or figures where there's more than one shape, you're going to use that knowledge to start creating your artwork. On Thursday, you will have a rough draft of the image, and you want to make sure that you have a good idea that you've used 3 different shapes, that you have 12 figures in total, and then you figure out the area. And then on Friday is where you create your final draft of the image. If you have the ability to decorate it, such as with matte pencils or crayons, then you can decorate it. But again, as I mentioned earlier, refer back to the rubric to ensure that all the criteria are met. So, just to recap, this week, you 6th graders out there, you're creating an art project that utilizes composite figures, and you're going to use that composite figure to calculate the area of the final image. Remember that you want to have triangles, parallelograms, rectangles, trapezoids, and if you're willing to stretch yourself, you'll have the area of circles too. So 6th graders, let's review some information about those images very quickly. In elementary school, you studied how to find the area of a rectangle. Now, initially, you just took a rectangle and you counted how many unit squares were in the rectangle. And you might have noticed that there's a more efficient way to do this. I don't have to count all of the squares each time. I could just count how many columns and how many rows that I have. And in this situation, you'll notice that I have 3 rows, 5 columns, so that 3 times 5 is equal to 15. And if I counted up each of these little unit squares, I would find that this rectangle is 15 square units. So this is what you did in elementary school. So let's just remember that any time that I'm finding the area of a rectangle, I'm going to multiply the base times the height. So that's very important to remember. No matter what shape I have for my rectangle, I'm going to be multiplying the base times the height. And a very important thing to remember is that the base and the height have to make right angles. The fancy big mathematical word for that is perpendicular. The base and the height always have to make a right angle. They always have to be perpendicular. So some of the things that you studied this year is that you started looking to see, well, what happens if I take a rectangle and I cut it in half? So we're going to take our rectangle here today, and I'm going to cut it right from one vertex to another. And I kind of gave away what happens. When we cut from one vertex to another, my one rectangle becomes 2 triangles. So when I used to have an area for a rectangle that was base times height, now I find out that if I just want to look at the triangle, it's half of that area. So in other words, the area of a triangle is 1/2 the base times the height. Now notice, no matter how I turn it, that my base and my height always have to make that right angle. They always have to be perpendicular. And it can look differently for different types of triangles. My formula will still be the same, 1/2 base times height, but notice that this time the base and the height are not the sides of the triangle, they're inside. And then, this one's always a little more difficult. When I look at triangles like this, some of the situations is that my height may actually fall outside of the triangle. So this would be the height, and this is the base. So this is the base, and this is the height of my triangle. Now, we're going to use our information about rectangles and triangles, and we're going to expand it to look at parallelograms and trapezoids. So in your lesson this week, they ask you to take 2 different types of rectangles, and they wanted you to have 2 different types of squares. And I just cut these up from pieces of paper. I made them colorful so that they would show up a little bit better. And then for some of you 6th graders, because we're starting to bridge into 7th grade, if you'd like to challenge yourself, we can even talk about circles. So if you have something circular that you can trace, please feel free to find a circle that you can trace. So in the lesson for this week, we ask you to find 2 rectangles, 2 squares, and 2 circles. And remember, you can make them out of paper. I traced some things. This is a cup that I have in my house that I traced. You can use boxes that you have. This is a soap box. I also used a toothpaste box this week. And some of you, as we start looking into the 8th grade lessons, we're also going to need cylinders. So I used just an old toilet paper roll. So anything that you have around the house will work. Now in our lesson this week, the directions ask you that you're going to cut these in order to make a parallelogram and a trapezoid. So we're going to start, the directions say to start, by looking at the square first. And the directions ask you to cut from a vertex to the other side. So I am going to go from a vertex, right here, I'm going to go from my vertex, just to another side. So I'm going to cut like that. And I'm modeling what you'll be doing in your lesson. Now, we're asking you to shift this around until I can get a parallelogram. Now remember, a parallelogram has two parallel sides. So that's not gonna work. That doesn't work. I'm going to try. Oh my goodness, that works. That's a parallelogram. So I started out with a square. Remember, I cut from one vertex to the other side, and then I shifted this little piece around until it made a parallelogram. And what we're asking you to do in the lesson is to describe if you think that the area of this parallelogram is the same as the square, or is the area of the parallelogram bigger than the square or smaller than the square. And we ask you to repeat the process with a rectangle. So again, if you start out with a rectangle, and I'll model that for you, we're asking you to cut from a vertex, from one of the points, to the other side. So I'm going to cut just to my other side, anywhere, doesn't matter. And then we're going to ask you to rotate. And I'm wondering, let's see. Nope, that doesn't work. Because remember, I'm trying to make a parallelogram. That doesn't work. That works. Okay? Now, the next part of the lesson that we're asking you to do this week is try to create a trapezoid. So remember, a trapezoid has two parallel sides. And so again, we'll start with our square. You're going to cut from a vertex to the other side. So this is similar to what we did before. We're going to cut from our vertex to the other side. And this time we're going to move the pieces around, not so that we can make a parallelogram, but so we can make a trapezoid. That's going to be trapezoid. Ugh. Let's see, let's go this way, see if that works. That is not a trapezoid. That's not a trapezoid. That's sure not a trapezoid. Ugh. What am I gonna do? Oh, that's a parallelogram. This is getting really hard. Wait a minute. I flipped over my piece and now I have a trapezoid. Notice it has two parallel sides and I have a trapezoid. So again, we want you to ask, if I have this trapezoid, how does its area compare to the original square that I had? Is it bigger? Is it smaller? Is it equal? So we also ask you to do the same thing with a rectangle for later in the week. Now our goal is that we want you to create something that we're calling a composite figure. A composite figure is an image in math that's made up of multiple figures. So I'm going to take my squares, my rectangles, my triangles, and I'm going to ask you to put them together and to create a picture if I put them together without overlapping. And this morning I made one, and I want you to see if you can figure out what it is. Let's see. This is my figure. Can you tell what my figure is? I spy a fly. Can you see his eyes are made up of 2 semicircles. It was a circle that I took and I cut in half. I have a triangle. I have a rectangle. And I have 2 parallelograms. This is called a composite figure because I've taken the different pieces, I've lined them up along their sides, and nothing overlaps. This is called a composite figure. So your project by the end of the week is to create one of these composite figures. And so the one that I created, I'm going to show you. I pulled the pieces apart so that you can see them a little bit better. I made a card for my mom for Mother's Day. If I put all these pieces, smush them in a little bit closer together, they'll make a composite figure of a flower. Notice I've got triangles, I've got some trapezoids, I've got some rectangles. I just made these with colored pieces of paper. And then I made a little heart for my mom. This is to Mom. So this is what we're asking you to do this week and to calculate the area for each of these figures. So very quickly, let's remind ourselves all of the area formulas that we're looking at this week. At the very, very basic level, we start with the area of a rectangle. And remember that we find the area of a rectangle by base times height. We use it to figure out the area of a triangle. And the area of our triangles is half of that. So it's always 1/2 base times height. That's the area of my triangle. And I'm looking, okay. And then the next thing we do, here we go. I knew I had my triangle somewhere. I cannot find my triangle, so you'll have to believe me. Oh, there it is. 1/2 base times height. And then we use that to find our parallelogram. And then we use that to find the area of our trapezoid. And then the last thing that I want to share with you, because some of our 6th graders, like I said, y'all are stretching into circles. The area for a circle, and you're going to learn this in 7th grade, is pi r squared. And I want to review this because we're going to need this for some of our projects for our 7th and 8th graders. The area of a circle is pi. You take the radius and you square it. Now that is concepts that our 6th graders, that all of you can do. We're just throwing in a new shape. Pi, we're going to represent with the number 3.14 times r squared. Thank you. Y'all did a great job reviewing how to calculate the area of 2-dimensional figures. So now let's transition into 7th grade mathematics. For the project in 7th grade mathematics, you're going to start looking at the volume of rectangular prisms, triangular prisms, rectangular pyramids, and triangular pyramids. Now, did you notice something about all those different names I just said? Did you notice that some of them are prisms and some of them are pyramids? And you might have noticed that some of them have rectangular bases, while the other ones have triangular bases. That's important because we just reviewed from our 6th grade unit how to calculate the area of rectangles and triangles. And guess what? You have to use that information to calculate the volume of 3-dimensional figures. So we're going to use that information in 7th grade. Our question for this project is, how do you find the volume of composite 3-dimensional figures? This project has you creating a robot. You can either just draw the image or you can actually create the figure. I made mine out of scraps of things that I had around the house. By the end of the project, you need to use at least 5 different figures, and your robot needs to have a head, arms, a body, and legs. And in 7th grade, again, we're just focusing on prisms and pyramids. We're going to ask that you write down the name and measurements of the shapes that you use, each of the component objects, and then you'll calculate the volume of each body part of your robot. And we'll use that to calculate the total volume of our robot. So let's look at what we're going to do each day. By the end of Monday, you're going to have reviewed how to calculate the volume of prisms, both the rectangular and the triangular type. On Tuesday, you're going to have reviewed how to calculate the volume of pyramids. Again, looking at pyramids that have bases that are rectangles and bases that are triangles. On Wednesday, you're going to learn how to calculate for a missing dimension. And I'm going to give you the volume and some of the other dimensions, and then you're going to solve the equation. Do you remember how to do that? That was in our prior lessons, solving equations. So we're using that prior knowledge to help us out here. On Thursday, we put it all together. I'm going to give you all sorts of different figures, some of them prisms, some of them pyramids, some of them might even be composite. And you're going to determine the volume for those calculations. Finally, on Friday, you get to create your robot, and you're going to build it or draw it out. Now, I want you to remember a couple of things about the projects for this week. Number one, we're creating a robot made of composite 3D figures, and we're going to calculate the total volume. Remember that you need to use at least 5 different figures. They need to represent the head, arms, body, and legs. You're going to write down the name and measurements of the shape and each component object. You're going to calculate the volume of each body part of your robot, and then you'll total the volume for your robot. And one last reminder, I want you to be sure to keep your robot because you're going to need it for next week's lesson too. So let's stop for just a second, and I'm going to introduce you to my robot. I made a robot and I've called him Tiny Todd. Let's check him out.
All right, I would like to introduce you to Tiny Todd. Tiny Todd is my robot. I think he looks great. And we're talking about composite figures. So remember, we got to look at the different pieces of him. I've got 2 legs, and I'm not sure if you could tell, but these are 2 triangular prisms. And so this is what I created his legs out of. 2 triangular prisms. And then he has 2 little hands. You see how they come to a point? These are these are rectangular, because their bases are rectangle, pyramids. And then I have his body and his head. And his body is a rectangular prism, and so is his head. So I'm going to move him out of the way for just a moment. This is his body, and this is his head. Remember, these are the nets that if I fold them up, these will be the pieces. That's where his head goes. And his legs, remember, are triangular prisms. So there's one of his legs. And these are important because we're asking you to find the volume of each of these. And volume, the formula is base area times height. So I need to find the area of the bases. So remember that I said in his legs, we're going to look at his legs for just a moment. His legs are triangular prisms. I know that because the prisms are parallel, and there are 2 of them that are congruent to each other, and that's the 2 triangles. And then each of the lateral faces are rectangles. So remember, we find the base area, so we want to find the area of this triangle, and then I'll multiply it by the height, and the height connects one base to the other. So find the area of the triangle, 1/2 base times height, and I'm going to multiply it times the height of the prism. So this is just looking at one of the legs. If I look at one of his little hands or his arms, this is a rectangular pyramid. So when I fold it up, this becomes one of his hands. And to find the volume, I want to find the area of the base. That's a rectangle, right? So it's going to be base times height. And I multiply that times the height of the pyramid. And that is how tall my pyramid is whenever it sits up straight and tall. So we're asking you to create your robot. I'm bring back Tiny Todd. And then we're going to ask you to report on the volume for each of his composite pieces. So in the directions, I tell you, I want to know about his head. It's a rectangular prism. I need to find the measurements of the base and the height, because remember, his head is a rectangle. And then I need to find the height of the prism. And so for each of the body parts, I go through and I do this. And remember that the focus in 7th grade is on triangular prisms and rectangular prisms, triangular pyramids, and triangular prisms. You don't have to cover your robot in tinfoil. I just thought it made him look cool. Thank you.
All right. Did you like meeting Tiny Todd? I did my best work on him, so I don't want any of you making fun of my tiny little robot. So now let's look at the 8th grade project, and it's going to look very similar. In 8th grade, you're going to focus on solving problems involving the volume of cylinders, cones, and spheres. Now I want you to think for just a moment. What do cylinders, cones, and spheres have in common? A cylinder is like a soup can, a cone is like an ice cream cone or a birthday hat, and a sphere is like a basketball. What do those all have in common? You're right. They all involve circles. So we're growing from our understanding about rectangular prisms and pyramids and triangular prisms and pyramids. And now we're moving into bases that have circles. And that's why it's so important for us to understand how to find the area of triangles, rectangles, and now circles. So remember, some of you who were in that 6th grade lesson were stretching yourselves into that understanding of the area of circles that we must master in 7th grade. We're going to use all of that information to find the volume of our 3D figures. Our guiding question is once again, how do you find the volume of composite 3-dimensional figures? All of the projects this week are focusing on y'all taking little bitty component parts and either calculating the area in 6th grade or the volume in 7th and 8th grade. And we take those component parts and we add them together to make one composite figure. So that's our guiding question for all 3 projects. How do you find the area or volume of your composite figure? So let's look at the project overview for our 8th graders. You too will be creating a robot. It's got to have 5 figures, and please make sure that all of your robots have a head, arms, a body, and legs. But you need to include cylinders, cones, and spheres. Now, it will be okay if you use prisms or pyramids in your robot, but we definitely need to make sure that you've got some cylinders, cones, or spheres on your robot as well. Just like with 7th and 6th grade, we want you to write down the name and measurements of the shape for each component object, and then calculate the volume for each part of your robot, and we'll find the total volume of your robot. So as you go through the week, you're going to review different things. On Monday, you're going to review how to calculate the volume of cylinders. On Tuesday, we'll review how to calculate the volume of cones. On Wednesday, you're going to review how to calculate the volume of a sphere. And then on Thursday, you're going to practice all different shapes. I can give you cylinders, cones, spheres. I could even give you some of the stuff from 7th grade. And you might even have to start putting them together in composite figures. So Thursday is our check for understanding day, because then on Friday, it's robot day. That's the day you're going to create your robot. You can either draw him or her on paper. You can build it from paper or recycled objects. And in just a few moments, I'm going to introduce you to Tiny Tanya. So let's recap our 8th grade project. Students are going to create a robot. You're going to utilize 3D figures and calculate the total volume of that figure. Please remember the must-haves for this project. You got to have 5 figures that represent the head, arms, body, and legs. You need to write down the name and measurements of each shape of the component object. And then you've got to calculate the volume of each part of your robot and the total volume of your robot. Once again, I'm going to ask that you be sure to keep your robot because you're going to need it for next week's lesson. So, just to review, sixth graders, you are creating a composite two-dimensional picture that focuses on area. Seventh grade and eighth grade, you're both creating composite robots, but you may have different components. Seventh grade, we're focusing on prisms and pyramids. Eighth grade, we're focusing on cylinders and spheres. We can't wait to see what you create because we're going to use them for next week.
I'd like to introduce you to Tiny Tanya. She is a friend of Tiny Todd's. Can you tell? So in eighth grade, the difference in the project is we're asking you to use cylinders and cones. Can you see I made a cone out of her hat and her head is a cylinder. So very similar. Remember that all of the figures in eighth grade are based on circles. So it's still the same process that we used in seventh grade. We're asking you to create a robot, and then we're asking you to list out all of the component parts. This is her hat. It's a cone. So I need to know what the radius is of that cone. And then I need to know how tall that cone is. For her head, it's a cylinder. What's the radius of the circle that makes up her head? And then how tall, or what is the height of that cylinder? And then her body, I used a rectangular prism. For her arms and hands, I used rectangular pyramids. And then for her legs, I used triangular prisms. So we're asking you again, you list out each of the body parts. You tell me what the shape is. You give me the measurements or the dimensions for each of the shapes, and then you calculate my volume. Remember, volume is base area times height. But when I have anything like a pyramid or a cone, I have to take 1/3 of that measurement. So for those, it's 1/3 base times height. Thank you. Tiny Tanya and I thank you for joining us today. We would love to see your robots, so please feel free to take pictures and post them on HISD at home. You can use Instagram, Facebook, or Twitter. Hope you have a great week. Again, my name is Alissa Howell. I'm the Secondary Director for Houston ISD Mathematics. Have a great week.